Hello everyone, in this video we are going to continue the discussion of mathematical induction. In last class we had seen what mathematical induction is and we had also discussed some problems. Today we will also start with a problem, so let me write the problem over here. So the problem says that prove that 2 to the power n is greater than prove that 2 to the power n is smaller than equal to n plus 1 factorial. So pause the video for a second and try this problem on your own. I hope and I believe that all of you can do this on your own if you had seen the last video of mathematical induction. Now let me give you some hint. As it says that 2 to the power n should be smaller than equal to for all n greater than 1 or all n greater than equal to 1. So basically for all the natural numbers. So what would you do? Firstly, you should see that whether it is true for n equal to 1 or not. So I hope that you all have checked it. Now let me also solve this problem, or rather prove this problem. So what does this problem say? Let's check for n equal to 1. So for n equal to 1, 2 to the power n equal to 2 to the power 1, that is 2, and n plus 1 factorial is equal to 1 plus 1 factorial, that is 2 factorial, that is equal to 2. Okay, so it is true for n equal to 1. Now let's suppose that this is true for some n equal to k. Let it be true for some n equal to k. Let it be true for some n equal to k. Now if this is true for some n equal to k, then we have 2 to the power k will be smaller than equal to k plus 1 factorial. I hope that it's clear till now. Now checking for n is equal to k plus 1. Now when we check this for n equal to k plus 1, then we get 2 to the power k plus 1. Okay, now we have to prove that 2 to the power k plus 1 is smaller than equal to k plus 2 factorial. I hope that it's clear till now. Now let's move on and let's see what this answer says. So here we can see that it is 2 into 2 to the power k. I hope that it's clear to you how I have written this 2 to the power k plus 1 is equal to 2 into 2 to the power k. And we already know that 2 to the power k is smaller than equal to k plus 1 factorial. I hope that it's okay. So we already know that it is smaller than 2k plus 1 factorial, and if we multiply 2 into that, then we can get it is smaller than 2 into k plus 1 factorial, which will be smaller than k plus 2 factorial. So from here on we get the answer that this particular stuff, that is 2 to the power k plus 1 is smaller than equal to k plus 2 factorial. So I hope that it's clear how we proved this by using the principle of mathematical induction. Now we move on to the principle of strong mathematical induction. I had already told you in the last video that we will discuss it in the next video. So what does the principle of strong induction says? So what does it say? Let's move the board a bit and let's see what does it say. So what we are going to discuss is principle of strong induction. What we are going to discuss is principle of strong induction. Now what does it say? It says that let S be a subset of n. Let S be a subset of n. Okay, if 1 belongs to S, the first statement, and if 1 belongs to S, and for every k belong to n, if 1 2 3 till k also belong is the subset of S, is a proper subset of S, then we can say that k plus 1 is a subset of S. I hope that it's clear to all of you. Now I will give you some problems to try. So let's flip the page and see what are those problems. So the very first problem that we are going to try is that you have to prove that 3 plus 11 to 8n minus 5 will be equal to 4n square minus n for all n belongs to n. Now I very much believe that I'm sorry, the problem is not in the frame. Now the problem is in frame. So the problem was that you have to prove that 3 plus 11 till 8n minus 5, the sum of all these numbers is equal to 4n square minus n. I hope that it's clear, the question is clear to all of you, and I firmly believe that all of you can solve this particular problem. Now let me give you one more problem. So what does the another problem says? It says that prove that n cube plus 5n is divisible by 6 for all n belongs to n. For all n belongs to n. Again, I believe that all of you can solve this problem. Now one problem I would solve with you. So let's go to that problem and let's see what does that particular problem say. So here we have to prove that 2n is smaller than n factorial for all n greater than 4. For all n greater than equal to 4. Okay, let it also be a homework for you. I believe that you can also do this. Now let me take another problem. In this problem we have to prove that n is smaller than equal to 2 to the power n for all n belongs to n. Now if you don't know this symbol stands for all. I hope that it's clear. This symbol we will use many a times, that's why I told you this symbol. Now when we move on to the solution of this particular problem, let's check whether this is true for n equal to 1 or not. So checking for n equal to 1, we are doing its proof over here. So for checking for n equal to 1, what do we see? We see that n, that is 1, is indeed smaller than 2 to the power 1. So it is true for n equal to 1. Now let it be true for some n equal to k. So when it is true for some n equal to k, then we have k is smaller than equal to 2 to the power k. Now checking it for n equal to k plus 1. So for k plus 1, we have to prove that k plus 1 is smaller than 2 to the power k. So let's try it. So here we can write k plus 1 is equal to k, and we already know that it would be smaller than 2 to the power k plus 1. I hope that it's clear. How I wrote this. As we know that k is smaller than 2 to the power k, then we can write k plus 1 is smaller than equal to 2 to the power k plus 1. Now from here onwards, as we know that 2 to the power k plus 1 would be greater than 2 to the power k plus 1, from here we get k plus 1 is smaller than equal to 2 to the power k plus 1. I hope that it's clear how I solved this. This is the way in which we will prove different theorems or different statements using mathematical induction. In the last video I had already told you that what is mathematical induction. So it is a way of proving statements in mathematics. This process of proving using mathematical induction would be used in various theorems of real analysis, and we will see how we use this method of proving of mathematical induction to prove the different theorems. I hope that this video was helpful for you. I hope that all of you can solve these 3 problems. If you can't solve any one of them, you can just comment. I will take these problems in the next video. Thank you very much for watching the video.